let's do the finish trees, all the missing problems on trees. Let's do all of these. This looks like nice medium stuff. Okay, you're given an single-threaded CPU. You're given n tasks labeled from 0 to n minus 1 from a 2D integer array task, where task of I equals NQ time and processing time. NQ time means that the ith task will be available to process at NQ time and will take processing time to finish. Okay, that makes sense. You have a single threaded CPU that can process at most one task at a time. Okay. You have a single threaded CPU that can process at most one task at a time and will act in the following way. If the CPU is idle and there is no available task to process, okay, so you have a single thread that processes one task at a time and will act in the following way. If the CPU is idle, there are no available tasks to process, the CPU remains idle. Okay. If the CPU is idle and there are available tasks, we choose the shortest processing time. Okay. If multiple tasks have the shortest processing, it will choose the task with the smallest index. Okay. Once this task is started, the CPU will process the entire task without stopping. The CPU can finish a task when then start a new one instantly. Okay. Return the order in which the CPU will process the task. Okay, this is pretty cool. So we return the indexes, I assume. Yeah, makes sense. The events go as follows. At time equals 1, task equals 0. This is available to process. Available task. Okay, let me think about this. So this means task 0 means that the I task will be available to process at NQ time. So 1, 2, 3, 4. Okay. The events follow. At time 1, task 0 is available to process. Okay. I'm thinking of I have some kind of idea here. So we can have like a time equals, okay, so there should be, I want us to like have like something like time equals 1, 2, 3, like, so we can have, okay, no, we'll have a map where it's like at NQ time to time to time, or what is this, not time, NQ time to I guess, but does that make sense though? Like there should be no NQ time, right? So that the I task will be available to process at NQ time and will take processing time to finish. The events go as follow. Time with task 0 is available to process. Okay, so I'm having a hard time understanding this. So okay, I understand the problem, but I'm trying to figure out the intuition. Yeah, I think for sure we use a heap, but what are we storing in the heap? I think the heap we're storing is time, I think. We could have like some kind of global time, I think, like a global time, but what do I do here? What do I do? If the CPU idle and there are available tasks, the CPU would choose the one with the shortest processing time. If the multiple tasks have the same short time, it chooses a task with the smallest index. Okay. A time equals 1, task 0 is available to process. Available tasks 0. At also time 1, the CPU starts processing tasks, so they're so I want to say like okay, there should be time, so 1 through 1, 2, 3, 4, 5. Is it even worth waiting for it? I think I should do like I can do like min max here, right? Like I can do like the range of time to go. Or it doesn't even matter. There's no even point of having a global time. I think I just process them as they come. But I sort by ascending NQ time, right? Right. So let's assume they're sorted for now, but I probably could have to sort them. So right now time is 1. Okay, so we can just kind of look at it, right? So we'll look at time is 1. So time is 1. Time is 1. What am I trying to do here? So I remember doing a similar problem to this. It's like we process that we order them by time or like events. So time is 1. And then they'll be done. A task is 0. Basically they start at 1 and then they take process the 2. So the processing time, so they'll be done at time 3. I believe that's true, right? Yeah. So every time something is done, we add it to the output. So let me map everything out. So task 1, it's going to be 2, 4, done at time. So we start at that time 6, right? Time 6. Task. Oh shit, hold on. At time is 2, task 1 available to process. Wait, hold on. Let me see this because it doesn't end at time 6. Hold on. So also time 1, the C part starts processing. Okay, I see. We should do okay, I have an idea now. So we should have like a current task, right? And we continually add that, but it gets sorted. It's like a heap, And at time 2, the task 1 is available to process. Available task equals 1. At time equals 2, the task 1 is available to process. Task 1 is available to process. Okay. Oh, I see. We added to the... Okay. We can't work on it, though. So current task is 0. All the tasks, so it's task 0. We'll have like a output as well. So we'll do output. Well, not yet. We can't. There's nothing in output. So there's current task. We add 0. Okay, so we add 0. Task at time 1. There's also processes that we can pop it out. Okay. At time 3, task 2 is available to process. Available task equals 1, 2. Also time 3. The CPU finishes task 0 and task processing task 2. Okay. Okay, so right now we add. Okay, we're processing. Currently processing. Right. Current task. There was 0. Now we move to the other. I guess whatever. This could be another heap as well. Right. Now we time. That was time 1. Now let's do current time. Let's do time. Time was 1. Now it's gonna be time 2. So in time 2, task 1 available. This becomes available. So let's put it in a current avail. Let's just do tasks. So we'll do now time at 1. This guy is ready to be processed. This guy is ready to be processed, right? So, well, not ready to be processed, but task 1. Okay, that's done. Okay, we can't process it now because this guy's still doing it right now. Time is 3. Yep. So time is 3, and then the task is available to process. Task 2 is available to process. Available task equals 1 to 2. Yep. So I hope. Okay. Starts processing task 2 as it is the shortest available task. Okay. But at this time is 3. Wait, why do we start tasking? This has a shorter processing time than this task. So task is 1, 2. So press start tasking. Okay, so task is actually going to be sorted. Okay, so it's going to be sorted by I think task is sorted by processing time. Right? And we'll have okay, yeah, sorted by processing time. I guess it's a double heap. Okay, I can see 2 heaps to be honest. Available task, yep, shortest time. Also at time 3, task, that one becomes 0, so we finish that. And you know, I just realized I don't really need a currently processing, because I just need to put them in the correct order, right? I don't really care. Like, I'm not going to actually simulate the processing. I just need to know when to put it. Like, who's going to go first. So, okay. I kind of have a better idea now. I just need to do, so we do current task, right? So as soon as we put it in currently processing, that's your answer, basically. We don't even need an output, right? Like, as soon as it's available to be, you know, processed, I guess. Oh, I see. No. I can't just keep putting it in, you know? Why not? Just put it in as soon as it's available to process. Yeah, so I'll put task 1, right? Then I'll try to put task 2, right? Or task 1. Oh, I see them. I actually have to have a state of that, because that's why task 2 actually goes into task, gets put first in task 1, because of task 1 was idled. Never mind. Okay, so I do need to keep track of the state. Okay, I feel like it's 2 heaps. So one is sorted by processing time. The other is I'm gonna assume that these are the NQ times. I'm only gonna go off that, and I'm also gonna check for, basically, if the I guess if the NQ time, then I can pop out the thing. So I'm gonna store the task ID and the end time, which is basically NQ plus processing. Yeah, and then that should be it. Let's try that. So let's do this. I'm gonna task.sort by, do I sort by, yes, NQ time. Okay, so, and then for every NQ and process, or what's a better word? Let's do ET and PT in tasks, right? We'll have also, hold on, we'll also do all tasks, right? And we'll also have currently processing. Right? I'll just store this as like that. Since only one at a time. Do that. So, oh my god, this is a bad variable. Tasks. Let's do available tasks. Available. Okay, so for every ET in tasks. So, okay. Okay, I think I'm gonna just make this a list, because this just makes the operations easier. Okay, so first thing is to process, is to add it to available tasks, right? So actually I need the index as well. So I'll add that there. So available tasks. I guess we'll also do res here. Return res. Okay, just still not. We still need to think about something. So okay, what do we do now? So add to the task. So put the task. So our processing time. So we'll put basically available tasks, right? The append, or actually it's gonna be a heap push available tasks. We'll put the processing time pt and I. We'll put it in there. Also, currently processing. If not okay, let's say if processing. Let's do if not processing. If not processing. Right. So if there's nothing being processed, and there are available tasks, right? Pop the ink. Let's do heap pop. Heap pop available tasks. Heap pop, yeah, just heap pop, and that's gonna give me yeah, available tasks, which is gonna give me, right? Process process time and ID index, right? And then process time. Okay, so we have process time, so we'll do we want to do processing dot append the end time. So right, what was the thing? Okay, task actually, which is the index, and then we'll do process time plus the EQ, or the ET plus the process time. Okay, so if not processing and available tasks, the process time index heap pop. Okay, so if there's nothing processing and there are available tasks, otherwise, yeah, otherwise, if that's not the case, then yeah. Now I need to do another thing. Is let's say if the current time, right? If ET equals the processing time at, let's just do this first index, right? At 1, I think. This is where we fit like the ending time. Then what do we do? So let's say ET equals processing 0, 1, right? That means it's time to remove him. So yeah, so ET equals processing at the first index, or yeah, and then we'll do processing dot append or pop, right? Pop, which will give me the index and end. Well, I don't really care about this value, to be honest. Right, index pop that, and then we do res.append index. Okay, so that kind of makes sense. So let me like walk through this. So sorted by the in NQ times, and then we're gonna iterate through. We're gonna first check if the processing. Okay, so if processing and ET equals that, right? So we'll go through if processing, nope. If not processing and there's available tasks, well, that's going to also be false. So let's just push available tasks, right? So is there anything processing? No. So okay, now the current state is going to be available tasks is going to be, what do we add here? Available task is the PT, which is processing time, which is, I think, 2, and the ID, which is 0. Oh shoot, this is bad. Wait, if not processing and available tasks, then process. Oh yeah, that's what I should have done right here. Like, okay, the first iteration, if not processing, if processing, nope. Yeah. Oh shit. Okay, I messed up here. I think I should make this an if else. Elif else. I want to do only one of these at a time. Okay, so does this make sense? Right? Okay, so if there's right now processing is empty. So okay, so is it processing? No. If not processing, yes. And is there available tasks? Okay, that's the problem. If there's no process, okay, that's why I should always push this first. Push first, right? Let's always push first, and then make these separate branches. Okay, so we push the thing in, so it's gonna be available task is 2-0, right? If processing, no. If not processing and available task, yes, there is. So let's take the processing, so pop them out. So we're gonna get here minus, it's gonna be 2-0, right? And then we do processing dot append, so we'll append the index, which is 0, and process time, so it's going to be, so NQ time, so it's 1 plus 2, which is equal to 3, so we finish at 3. So we're going to put in task 0 is going to end at time 3. So that's right here. Task 0 is going to end at time 3. Okay, perfect. Okay, so we're going to push 2-4. So we're going to push 2-4, so that's going to be task 1 and task 1 at 4. Okay, task 1. Okay, if processing, yes there is, and the processing that here, no, that's going to fail. If not processing, well, that's not true. So we both fail, so we actually skip that entirely. Yeah, so they're just going to be in the available task. Let's do time 3. We also add that again. Wait, so let me first add that available task first. So it's going to be PT, so processing time for 2-4, which would be 4, then task ID, which would be I, which is 1. It's going to take, yeah. Task 1 is going to take at least 4 processing time. Then we go to task 2. None of these checks out because there's something processing, and obviously if something is processing, it's not going to be that either. So now we need to put the available task, so that's going to be processing time for number 2 is going to be 2 at task 0, 1, 2. So task 2 takes processing 2, but again, these are sorted, so I need to put this right here. I'm gonna put this like this. Oh, also this is not here anymore. processing time of 2 of task ID 2. Right? Processing time of 4 of task ID 1. Okay, now. Okay, so now what? So we go through processing and ET processing. Okay, we're not processing index time. Okay, now we go to time 3. Well, we just added 4-1. Now let's check processing. Yep, and this actually executes here. So we pop them out, and then res.append index 0. Yep, and then there's not going to be anything in processing, and there's some available tasks. So we pop the available tasks. So it's going to be 2 time processing time of 2, and the current ET is 3, so it's going to end at 5. Yep. Okay, I think this should kind of work. Let's try it. GG's, boys. Okay. Oh, it's because I didn't enumerate. Okay, wrong answer. Oh, no. No. Okay, so why is this happening? Oh, God, this is bad. Okay, let me see. So, okay, let me start over. Why is this only adding 0? Okay, so he push. Right, he push. Let's push the available tasks. So, which is gonna be processing time of 2 and index 0, and then processing. Okay, so now that's what's in the thing right now. Is there anything processing? No. Is there nothing in processing and there's available tasks? Yes, there is. So we do that. But okay, so we'll do index, which is 0. So we're gonna put in 0 and ends at ET plus process time. So ET right now, I believe is 1 plus processing time is 2. So it's gonna end at time 3. Remember that, please. Okay, I don't know what's fucking happened. This should work. Okay. So time is 2. So available tasks is equal to 2 0. No. This is what's in here. Oh, this is also pop. So there's nothing in available tasks right now. Okay. So right now there's no available tasks, but there is something in processing. Okay. So this is here. Oh shit, hold on. I think I know why. I feel like this is supposed to be a while queue situation. I can't process them immediately because I think the time is gonna. Yeah, I feel like I need to do this more of a while because there's gonna be. I have to like keep going essentially while there's a basically while there's like still available tasks. Hold on. So maybe I'll do this instead. Do while available tasks. Not while available tasks. While processing or available tasks. While there's something to do essentially. Right? I don't think I need the for loop per se, so let me get rid of that. Right? While processing or available tasks, right? I'm not sure. Okay, hold on. Okay, I think this is all wrong. I don't know. I think the ordering got messed up with the dot sort. Hold on, let me restart real quick. So I think I need to order by enqueue, processing, and index. So let's do that. Indexed. task. We'll do indexed task dot sort. Dude, I fucking hate this shit. I don't know why that's a fucking key button. Dot sort. Okay, whatever. Okay, and then here I want to order them by enqueue time, process time, and index. Yeah, I think that's kind of what I'm trying to go for. Like for every task. Wait, so I need the two values. I want to put the enqueue time, processing time, and index for et pt I enumerate enumerate tasks. This is break. Hold on. Is that right? Is that right syntax? It's not right. Okay, okay, hold on. It's because I need to do index first. Yeah. Like that. Yeah, that should work. Okay, that's fine. Then we sort it. And then we'll have available tasks as our heap, which will store the index and then the PT time or end time. Or I'll do end time and then PT. So while, and then we'll just iterate through the normal one. So I is 0. So while I is less than length of tasks, because yeah, we can process them normal. Because I need to do a while loop because like we have to, like, it's gonna go beyond the scope of the tasks here. So if nothing in our available tasks. Oh, okay. Also, I think I'm gonna bring back that global time thing. So if not available tasks, and there's nothing, yeah, if not that, right? Okay, so if there's available tasks and the current time, right? If the indexed tasks at let's do ET, so it's the first one in there and the first one here, we'll just equal it to indexed tasks 0 0 enqueue processing, so we can essentially move the time forward, so we can like have like something to process. Okay, so then we'll do while I is less than, oh actually, and there's still available tasks. So while I is less than length of tasks, right? And the current enqueue time, right? And okay, so time while, so we want to put all the available tasks like these, like that are currently less than or equal to basically 3, which would be 1 and 2. We're kind of like time skipping here, but the thing is the order is always preserved, so we'll do the indexed task 0 0. Oh, not 0, so it's I 0. Yeah. And less than or equal to the current time. Then we'll do ET, PT, and index, which will be heap pop from available tasks. not available task. The indexed task of I, then available tasks dot append. Okay, so then we push these guys in here. Heap push we want to put basically the shortest processing time. So the shortest processing time and their index. Yeah. And then we move I on. So we know that we still have enough tasks to complete. So then now we could do PTI. From heap pop to available tasks, and then time will be incremented by PT because that's how much it's taken up, and then the answer is here, respawn index here. The order we time skip every time we do that, you know. We basically time skips all the stuff that we need to do every time we process a task. And of course, available task is going to be... Okay, this is wrong. Not in time. It's going to be PT, processing time, and their index. This should work, I think. Okay, I don't have res here. Oh. I should do this. What? What's happening? While I is less than length of tasks and available tasks. Oh shit, I need to put oh my god. Or. It's either or. Yeah. Should work, I think. Where's the append? Come on, bro. I'm spelling things so badly. Out of range? Doesn't make sense. Wait, do I... Oh, wait. Do I increment as well? Index out of range? How does that make sense? PT index. What am I doing wrong here? Oh, shit. I know why. There you go. It's working, but I processed them wrong. Am I sorting them right? ETPTI, ETPT. You, of course, sort them by ETPTI. Wait. No, I need to do this here, right? Tasks. Index tasks. Because I don't want to break out of bounds here, right? Why am I getting them in order? That's not what I'm trying to do, bro. Time is equal to index task of that. And oh my god, this is why. And index task of I. Less than or equal to time, I guess. Wait, what am I trying to say here? This doesn't make any sense. If there's no time, okay, if there's no task and there's if there's no available task, yeah, if there's no available task, then just move move on, I guess, move on to the next like available time. Okay, I need to do something. I think the condition is different. So we do index task of this greater than, and index time. Okay, this here. If there's no available task and the time of the next in queue, yeah, time of the less. I guess yeah, less than. Okay, if the current time and there's no available task, we should probably add more tasks. Check the next in queue time. All right, let's do equal to. No, a little better. I think that was a little bit better, but I'm not sure exactly why. Okay, just when is less than time. Okay. Let's do that instead. Fucking finally, bro. Holy shit. Alright, see you guys tomorrow.